Welcome back to a new build video. This time I was challenged by someone who had a rather unusual request. A person reached out to me and asked if I could build a 5-inch FPV drone for him, which in itself is not unusual, but it was the very specific requirements that were a bit unusual. The first requirement he had was that the drone should have a Radiomaster Gemini crossband receiver so he could fully utilize his Nomad module. This requires both 900 MHz and 2.4 GHz RX antennas, as well as the slightly larger XR4 receiver. And the next item on the list is that he wants to fly the drone with DJI Goggles 3, which means we need to use either an O4 or O3 air unit. He also mentioned that he wants a range of up to 3 kilometers, and he wants 15 minutes of flight time while flying cinematic chill flying. So all of this would have been fairly common requirements if it were a 7-inch drone or larger, but this guy wants it to be on a 5-inch frame, and perhaps the biggest challenge of all, it cannot cost much more than $500 US, which is quite tight considering how expensive parts are these days. But I decided to take on the challenge and see if I could satisfy his request. Keep watching to see the different solutions I came up with. For the frame, I went with a SpeedyBee Mario 5. It's solid, and at just $43, it's hard to find something cheaper. If you're interested in a more detailed explanation of how to build this frame, check out my other build video where I put the same frame together. I've linked it in the top right. The canopy on this frame where the camera is mounted is also integrated with a GoPro mount, but since an action camera won't be used on this drone, I designed a mount for the GPS there instead. This moves the GPS further away from the rear antennas and allows for a much shorter GPS cable, which in turn helps the GPS perform better. If you're interested in this GPS mount, I've uploaded it to my Maker World profile. For this project, I chose the iFlight Xing Pro 2207 motors. They are rated at 1800 kV, and for a set of 4, you're looking at $48. They're budget motors, but in my experience, they're efficient and surprisingly durable. This frame comes with proper arm protectors. They're not 3D printed in TPU, but made from molded plastic, which means the motor screws don't dig into them, which is a really nice touch. The only thing you need to be aware of is that the motor screws included with the motors are too short when using the arm protectors, so you'll need to get some 13mm screws as well. When mounting the motors, I always recommend using a bit of blue Loctite. Just make sure not to get any on plastic, since Loctite can dissolve it. The motors should be tightened firmly, but not too tight. If you over-tighten them, the screws can snap, and that's a problem you definitely don't want to deal with. Mounting the motors is probably the most boring part of building a drone, at least in my opinion. So let's fast forward until that's done. On the motor wires, I always like to use this. It's called braid sleeving and is made of plastic. You can find it very cheaply on sites like AliExpress or Amazon. Now the motors are in place and the wires are protected. The next thing I'm going to do is start installing the ESC and XT60 cables. The stack I chose is a SpeedyBee F405 V5 stack. I originally wanted to go for the V4 version, which is a bit cheaper, but it was no longer available. But the advantage of this one is that it has a switchable 9-volt back, which gives us the ability to turn the VTX on and off with a button on the radio transmitter, which is a handy feature to have. I've put together a dedicated video covering these features, so if you're curious, be sure to take a look. The Mario frame has a dedicated spot for the capacitor, keeping it out of the way. The important thing to watch is that the capacitor legs don't touch the frame or rub against it, which could eventually cause a short. So here I'm using a bit of T7000 glue to prevent the capacitor legs from resting directly against the sharp edge of the frame. I'm currently using mechanic rosin core solder with lead. It's the only one from AliExpress I've tried that actually works well. Since leaded solder is banned here in Norway, you have to order it from somewhere else to get good results. When measuring and cutting the motor wires, always leave a couple of millimeters extra. Cutting them too short is a real pain. I like to route them along the sides, which keeps everything looking clean. The reason I didn't solder the XT60 cable before installing the ESC in the frame is that it needs to connect to an XT60 connector at the rear of the frame. To get the correct cable length, it's best to have everything mounted first. The TPU part I designed for this build also includes antenna mounts for the receiver and the VTX. It also has a dedicated slot for the air unit. Here, the SMA pigtails are already installed. A good trick to prevent the XT60 socket from melting is to plug in an old smoke stopper while soldering. That way, you avoid overheating and deforming the connector. Another trick is to avoid using too much solder when pre-tinning the XT60 wires. They tend to absorb everything you feed them and can quickly become very stiff and difficult to work with. What I'm about to do now is a real pain in the butt, but it has to be done. If you've ever tried fitting a part into a TPU print that's just a little too tight, you know exactly the struggle I'm dealing with right now. Here, it's also important to cut correctly. The wires need to point slightly downward so they can pass underneath the VTX. If the wires end up too short, well, then you've got a problem. When soldering the XT60 connector, I prefer to use 400 degrees Celsius and always give it time to cool down before moving the wire. Now that the power wires and motor wires are fully soldered, I like to do a smoke test before moving on. I wanted to try out the smoke tester that comes with the SpeedyBee V5 Deluxe kit. It's a handy little tool that shows your battery voltage, so you can also use it as a battery checker. You can choose to pass 1 or 2 amps through it, and it has a simple on and off switch. The first smoke test is always a bit exciting. Even though I'm pretty confident in my soldering, there could still be a short or some faulty hardware. 3, 2, and 1. Green light this time too, so I'm good to move on. Next on the list is the VTX. The video system I've chosen is the DJI O4, the light version as some call it. But this doesn't quite look like what DJI shows on their website, you might be thinking, and you're right, this is Flywoo's modified version. Flywoo has taken an O4 Lite and placed it inside their own custom housing. They've replaced the lens on the O4 camera and mounted it in a frame with mounting holes that make it compatible not only with O4 Pro mounts, but with O3 mounts as well. Flywoo calls this kit the O4 Wide Air Unit Pro. It's designed to fix the narrow field of view on the O4 Lite and give you the same feeling as flying the O4 Pro. They didn't just change the lens, they also replaced the antenna with one that looks similar to the O3 antenna and swapped out the MIPI cable with one that appears to be 13 centimeters long. So with this kit, it suddenly makes a lot more sense to use O4 Lite on larger drones too, like a 5-inch build. I'm really excited to test this setup. The DJI O4 Lite has a theoretical range of up to 10 kilometers, even though it only transmits at 700 milliwatts. That should be more than enough for the 3 kilometers the owner of this drone is aiming for. And at around $150, only half the price of the Pro, this could quickly become my go-to setup for 5-inch builds from now on. Since I'm running an SMA pigtail to the VTX antenna, I need to remove the antenna Flywoo installed. It's also a good chance to see what they've done inside the protective casing. As you can see, they've applied some thermal paste, so the casing doesn't just provide protection, it also acts as a heat sink. One of the weak points of the O4 Lite is that the MIPI cable sits a bit exposed and can snap. Flywoo added some extra glue, but I'm adding a little more on top, just to be safe. That should hold it securely, it's well protected, and I've zip-tied the MIPI cable to a standoff so it won't go anywhere. At the end of the video, I'll do a quick range test and check the quality of the O4 footage, so stick around if you're interested in that. As I mentioned at the beginning, the person getting this drone wants it fully compatible with his Nomad module. He wants it to support both 2.4 GHz and 900 MHz. To make that happen, I'm installing the Radiomaster XR4 receiver. The downside of this setup is the two large antennas that need to be mounted, plus the XR4 receiver itself, which is a bit bigger than a standard nano receiver. I decided to mount one antenna horizontally on the underside and swap the other for a JEP RC tri-band stick antenna. The receiver also won't fit in the dedicated receiver slot on this frame, so it has to be mounted on top of the VTX. I'm using strong double-sided tape to mount the receiver on top of the VTX. This is where I usually mount the receiver, but it's a bit unfortunate that it doesn't fit under the VTX, which is where SpeedyBee intended it to go on this frame. So now I'm ready to install the flight controller, but before I do that, I want to protect and waterproof the XT60 pads. It's a tight space down there, so I think it's worth doing. I'm using my T7000 glue again. I really think anyone building drones should keep a tube of this in their toolbox. I'll put a link in the description. I also like to wrap the VTX and receiver wires with black cloth tape. It just makes everything look a bit cleaner. And yeah, maybe there's a touch of OCD involved. Now it's time to plan which UARTs I'm going to use on the flight controller. I always try to avoid routing wires straight across the board if I can. This flight controller comes with a dedicated DJI plug on UART 3. It outputs 9 volts, which makes it fully compatible with the O4 Lite. On UART 2, I'll connect the GPS. The magnetometer pads are placed on UART 4, but on a 5-inch build, I don't use a compass anyway. And the 4V5 pad will power the GPS through USB if I want it to. The buzzer pads are located here. The P+ and P- pads are new on this V5 version of the SpeedyBee flight controller. They provide a switchable 5-volt BEC, but I won't be using them in this build. And finally, the receiver will be connected to UART 4 and will also get power from a 4-volt 5-pad. The GPS I'm using is an HG-LRC M100 unit. I've been very happy with this one in previous builds, and with such a short GPS cable here, I expect to get well over 20 satellites quickly. So, placing the buzzer on this frame can be a bit challenging. I've found a method I usually use on Mario 5 frames, but it requires a bit of modification to the buzzer and a 3D printed part. If you go with this method, be careful with the heat when using a heat gun on the LiPo battery. Everything is finally in place. The GPS cable ended up really short and tricky to fit, but it looks good. Now it's just the final assembly of the top plates and antennas before it's ready for its maiden flight. I think this build turned out pretty well. Now I want to take you outside to test the range. I'll also check if there's any difference between biblade and regular props. I'm a bit unsure if biblades will give any longer flight time on a 5-inch. The battery I'm testing with isn't the best. It's a homemade 2500 mAh 6SL ion pack, but we'll see what kind of performance we get out of it. For the first test, I'm using biblade props. It's sunny and beautiful weather here in Norway, but there's a bit of wind, so I'll be a little bit careful when testing the range on the O4 Lite. So I've already done the initial tuning and checked that everything works as it should, so this isn't the maiden takeoff. Before flying long distances, I always test that GPS rescue is working properly just to be safe. And as you can see, I'm getting an impressive 27 satellites, so it should be pretty accurate.
Return to home.
Initially, I set it to climb 20 meters before it flies back home. Looks like that's working pretty well, and I'm ready to test the range. As I fly out, I'll speed up the footage since the flight itself isn't very exciting to watch. As I approach 1 kilometer, there's no sign of a weak signal. The video link is still at a full 60 megabits per second. At this point, I turn the drone around to make sure the signal doesn't drop when it's facing the other way. I did notice a slight drop to 58 megabits per second, but nothing to worry about, so I keep flying a bit further out. As I approach 2 kilometers, I'm actually running out of space without flying out over the ocean, which I wasn't too keen on doing. I can feel the wind from the south as I pass the mountain on the left, so I turn around here. Either way, I'm confident that hitting 3 kilometers won't be an issue, with almost full signal even at 2 kilometers. When it comes to the image quality on the O4 Lite, it's really impressive. The Flywoo kit does an excellent job, and if this were a blind test between the O4 Lite and the O4 Pro, I think I'd struggle to tell the difference. My take is that with this Flywoo kit, the O4 Lite can replace the O4 Pro on 5-inch freestyle drones while saving you around $150. Let me know down in the comments what you think. As for flight time, the goal was around 15 minutes. I'm coming up on 12 minutes now with a 2500 mAh battery. I'd say it should be possible to stretch that to 15 minutes with a slightly larger pack. Now I'm going to do one final test, this time with regular tri-blade props. I wasn't too impressed with the handling on the biblades, and on a 5-inch drone, I don't think biblade props make much difference when it comes to efficiency anyway. I can definitely feel that with tri-blade props, the drone flies much more stable and controlled compared to the biblades. That alone really makes the choice pretty easy. It looks like I'm actually getting more than 12 minutes of flight time with the tri-blade props. At this point, there's really no doubt about what I'll be recommending to the person getting this drone. That said, I'm still curious, in what situations are biblades actually more efficient? Thanks for watching this video. I've linked to my other video where I go through the new features of the SpeedyBee V5 flight controller I used in this build. Don't forget to subscribe, and I see you later. Bye bye.